Hello children, welcome to the science video session. Today we are going to learn the lesson electricity from physics of standard 7. Come, let's move on to the video session. Unit 2, Electricity. Introduction. In 1882, when it was sunset in the west, that miracle happened in the New York City. When Thomas Alva Edison gently pushed the switch on, 14,000 bulbs in 9,000 houses suddenly got lighted up. It was the greatest invention to mankind. From then, the world was under the light even in the night. Many countries began using electricity for domestic purposes. 17 years after the New York, in 1899, electricity first came to India. The Calcutta Electric Supply Corporation Limited commissioned the first thermal power plant in India on 17 April 1899. Around 1900s, a thermal power station was set up at Basin Bridge in Madras city and power was distributed to the government press, general hospital, electric tramways and certain residential areas in Madras. Today, electricity is a common household commodity. In your class 6, we learned about electricity and their sources, from operating factories, running medical equipments like ventilator, communication like mobile, radio and TV, drawing water to the agricultural field and light up homes. Electricity is important. So what is electricity? Can we see that? No, it is a form of energy like heat and magnetism. Come, let's get into the lesson to learn about electricity. Next, what is atom? We have learned that all materials are made up of small particles called atoms. The center of the atom is called the nucleus. The nucleus consists of protons and neutrons. Protons are positively charged, neutrons have no charge. Negatively charged electrons revolve around the nucleus in circular orbits. Electricity is a form of energy that is associated with electric charges that exist inside the atom. So, electric charge is measured in a unit called coulomb. 1 unit of coulomb is charge of approximately 6.242 into 10 to the power of 18 protons or electrons. Electrical charges are generally denoted by the letter Q. Electric current. The flow of electric charges constitute an electric current. For an electrical appliance to work, electric current must flow through it. An electric current is measured by the amount of electric charge moving per unit time at any point in the circuit. The conventional symbol for current is I. See here in the picture you can see the cross section area and the electric charge. So an electric current is measured by the amount of electric charge moving per unit time at any point in the circuit. Unit of electric current. The SI unit for measuring an electric current is the ampere, which is the flow of electric charge across a surface at the rate of 1 coulomb per second. So I is equals to Q by T. Here I is the current in ampere, Q is charge in coulomb and T is the time taken in seconds. We can use the triangle to find out the formulas very easily. If we need the value of current I, simply put your finger over current. So now this will leave the charge and time. So the formula will be Q into T. Next, if we need the charge Q, put your finger over charge. It will leave the current I over the time. So the formula will be Q is equals to I by T. Next, if you need the time T, simply put your finger over the time. So now the formula will be I by Q. Conventional current and electron flow. Before the discovery of electrons, scientists believed that an electric current consists of moving positive charges. This movement of positive charges is called conventional current. You can see the circuit given in the conventional current. So here the positive charge is flowing from positive terminal to the negative terminal. So conventional current flow from the positive to the negative end. After the electrons were discovered, it was known that electrons flow actually takes place from the negative terminal to the positive terminal of the battery. This movement is known as electron flow. The electron flow you can see in the given picture. See, the electrons are moving from negative terminal to the positive terminal. So this is called electron flow. So conventional current is in the direction opposite to the electron flow. Measurement of electric current. Electric current is measured using a device called ammeter. The terminals of an ammeter are marked with plus and minus sign. An ammeter must be connected in series in a circuit. Instruments used to measure smaller currents in the milliampere or microampere range are designated as milliammeters or microammeters. 1 milliampere is equals to 10 to the power of minus 3 ampere and 1 microampere mu A is equals to 10 to the power of minus 6 ampere. Next, potential difference V. Electrical charges need energy to push them along a circuit. Water always flows from higher to lower ground. Similarly, an electric charge always flows from a point at higher potential to a point at lower potential. An electric current can flow only when there is a potential difference. So, the potential difference between any 2 points in the circuit is the amount of energy needed to move 1 unit of electric charge from one point to the other. Unit of potential difference. Did you ever notice the precautionary board while crossing the railway track and the electrical transformer? What does the word high voltage denotes? The term mentioned in the board volt is the measurement for the electric potential difference. The SI unit of potential difference is volt and it is denoted by the letter V. Potential difference between 2 points is measured by using a device called voltmeter. The electric current flow from the higher potential level to the lower potential level is just like the water flow. See, then the waterfalls. The water at the top of the waterfall has more potential energy. Then the water near the base of the waterfalls has less potential energy. Likewise, electric current flows from the higher potential level to the lower potential level. Next, electrical conductivity and resistivity. So before we know the electrical conductivity and resistivity, we should know what is resistance. An electric component resists or hinders the flow of electric charges when it is connected in a circuit. In a circuit component, the resistance to the flow of charge is similar to how a narrow channel resists the flow of water. The higher the resistance in a component, the higher the potential difference needed to move electric charge through the component. We can express resistance as a ratio. Resistance of a component is the ratio of the potential difference across it to the current flowing through it. So, R is equals to V by I. The SI unit of resistance is ohm. Greater the ratio of V to I, the greater is the resistance. Electrical conductivity is represented by the letter sigma. Electrical conductivity or specific conductance is the measure of a material's ability to conduct an electric current. It is commonly represented by the Greek letter sigma. The SI unit of electrical conductivity is Siemens per meter. Next, electrical resistivity. It is denoted by the letter rho. Electrical resistivity, also known as specific electrical resistance or volume resistivity, is a fundamental property of a material that quantifies how strongly that material opposes the flow of electric current. The SI unit of electrical resistivity is the ohm meter. Sources of electric current. So in that we are going to see electrochemical cells or electric cells. An electric cell is something that provides electricity to different devices that are not fed directly or easily by the supply of electricity. Then, shall we produce electricity at our home? Yes. By a simple activity, we can produce electricity at our home. The materials required are zinc and copper electrodes, a light bulb, connecting wires, and fruits such as lemon, orange, apples, grapes, and bananas. The procedure. Set up a circuit as shown in the figure. Note the brightness of the bulb when the circuit is connected to a lemon. Repeat the experiment using other fruits listed. Do you notice the difference in the brightness of the bulb when it is connected to different fruits? Yes. What is the inference from the above activity? What makes enable the bulb to glow? Why there is a difference in the brightness of the bulb? The reason is that the fruits which you have connected to the bulb produces the electrical energy at different levels. The source which produces the small amount of electricity for a shorter period of time is called as electric cell or electrochemical cells. Electric cell converts chemical energy into electrical energy. In addition to electrochemical, we use electrothermal sources for generating electricity for large scale use. It has two terminals. When electric cells are used, a chemical reaction takes place inside the cells which produce charge in the cell. Types of cell: primary cell and secondary cell. In our daily life, we are using cells and batteries for the functioning of a remote, toy cars, clock, cell phone, etc. Even though all the devices produces electrical energy, some of the cells are reusable and some of them are of single use. Do you know the reason why? Based on their type, they are classified into two types, namely primary cell and secondary cell. First, primary cell. The dry cell commonly used in torches is an example of a primary cell. It cannot be recharged after use. The dry cell is shown in the picture. Next, secondary cells. Secondary cells are used in automobiles and generators. The chemical reaction in them can be reversed. Hence, they can be recharged. Lithium cylindrical cells, button cells, and alkaline cells are the other types of cells that are in use. The lithium cylindrical cells, button cells, alkaline cells, and the automobile battery are shown in the picture. Difference between primary and secondary cell. Primary cell. The chemical reaction inside the primary cell is irreversible cell. And what about in secondary cell? The chemical reactions inside the secondary cell is reversible. It cannot be recharged, but the secondary cell can be recharged. Example of secondary cells are lead accumulator, Edison accumulator, and nickel ion accumulator. In secondary cell, it is used to operate devices such as mobile phones, cameras, computers, and emergency lights. Example for primary cell: simple voltaic cell, Daniell cell, and Lagrange cell and dry cell. Next example for secondary cell are lead accumulator, Edison accumulator, and nickel ion accumulator. Primary cell, simply known as dry cell. A dry cell is a type of chemical cell commonly used in the common form of batteries for many electrical appliances. It is a convenient source of electricity available in portable and compact form. Dry cells are normally used in small devices such as remote control for TV, torch, camera, etc. A dry cell is a portable form of Lagrange cell. It consists of zinc vessel which acts as a negative electrode or anode. This you can understand by the given picture. The vessel contains a moist paste of sawdust saturated with a solution of ammonium chloride and zinc chloride. The ammonium chloride acts as an electrolyte. What is electrolyte? Electrolyte are substances that becomes ion in solution and acquire the capacity to conduct electricity. The purpose of zinc chloride is to maintain the moistness of the paste being highly hygroscopic. The carbon rod covered with a brass cap is placed in the middle of the vessel. It acts as a positive electrode or cathode. The cathode you can see in the picture, that is graphite rod. Next, it is surrounded by a closely packed mixture of charcoal and manganese dioxide acts as a depolarizer. The zinc vessel is sealed at the top with pitch or shellac. A small hole is provided in it to allow the gases formed by the chemical action to escape. The chemical action inside the cell is the same as in Lagrange cell. The dry cell is not really dry in nature, but the quantity of water in it is very small, as the electrolyte is in the form of paste. In other cells, the electrolyte is usually a solution. So that's what we are calling it as dry cell. Batteries. Batteries are a collection of one or more cells whose chemical reactions create a flow of electrons in a circuit. All batteries are made up of three basic components: an anode, the plus side, a cathode, the minus side, and some kind of electrolyte. Electrolyte is a substance that chemically reacts with the anode and cathode. Invention of the battery. On fateful day in 1780, Italian physician, biologist, and philosopher Luigi Galvani was dissecting a frog attached to a brass hook. As he touched the frog's leg with an iron scalpel, the leg twitched. Galvani theorized that energy came from the leg itself, but his fellow scientist Alessandro Volta believed otherwise. Volta hypothesized that frogs' leg impulses were actually caused by a different metal soaked in a liquid. He repeated the experiment using a cloth soaked in rain instead of a frog corpse, which resulted in a similar voltage. Volta published his findings in 1791 and later created the first battery, the voltaic pile, in 1800. The invention of the modern battery is often attributed to Alessandro Volta. It actually started with a surprising accident involving the dissection of a frog. Electric switch. Our country faces a shortage of electricity. So, wastage of electricity means you are depriving someone else of electricity. Your electricity bill goes up. So, we must use electricity very carefully and only when it is needed. We must use the electricity as long as we need it in our household activities. We shall use a switch to turn the current on or off. You may have used different kinds of switches to turn your household electric appliances on or off. Switches helps us to start or stop the appliances safely and easily. Here, the different types of switches are shown in the picture. First one, the tapping key. Next, the toggle switch. Next, the illuminated switch. Next, the plug key, rocker switch, and the slide switch. Electric circuit. It is difficult to draw a realistic diagram of the circuit. The electric appliances you use at home have even more difficult circuits. Can you draw realistic diagrams of such circuit which contain many bulbs, cells, switches and other components? Do you think it is easy? It is not easy. Scientists have tried to make the job easier. They have adapted simple symbols for different components in a circuit. We can draw a circuit diagram using these symbols. Symbols for bulbs, cells, and switches are shown in the given picture. In a cell, the longer line denotes the positive, the plus terminal, and the shorter line denotes the negative terminal. We shall use these symbols to show components in the circuits we draw. Such diagrams are called circuit diagrams. Types of electrical circuits. There are two types of electrical circuit. One is series circuit and another one is parallel circuit. First one, the series circuit. Two kinds of circuits can be made with two bulbs and a cell. In this experiment, we shall make one of them and study it. Look at the circuit with two bulbs and a cell and a switch given in the picture. So it is clear from the circuit diagram that the two bulbs are connected one after the other. The circuit diagram shows the sequence of the bulb and cell, not their real position. The way in which the bulbs have been connected in this circuit is called series connection. Now, make the circuit by joining the two bulbs and cell. Do both the bulb lights up? Do both glow equally bright? If one glows less bright, will it shine more brightly if we change its place in the sequence? So, change the sequence of bulbs and notice. Sometimes bulbs appear to be similar can differ from each other. So, similar looking bulbs do not always glow equally bright when connected in series. The circuit can be broken at several places, for example, between the cell and the bulb, or between the two bulbs, etc. Next, parallel circuit. The given picture shows a circuit in which two bulbs are connected in different places. This is the second type of circuit. Two bulbs in the circuit are said to be connected in parallel, and such circuits are called parallel circuit. Similarity and difference between series and parallel circuit. In series circuit, we are using the single loop connection, and in parallel circuit connected by branches. Then the bulbs are dimmer in series circuit, bulbs brighter in parallel circuit. Bulbs share power in series circuit, but in parallel circuit each bulb fully powered. All bulbs go out if one goes out in series circuit, but in parallel circuit all bulbs stay lit if one goes out. The similarity between the series circuit and the parallel circuit is the energy source, that is the battery we are using. Next similarity is the wires we are using. Signs to mind pricking. If an electrician attending an electrical fault at your home gets current shock, will you touch him in order to get rid of him from the current risk? No, we should not, because the current will pass to us also. Then, will you use the wet stick to beat him to avoid further effect of electric shock? No, we should not, because the wet stick is a good conductor of electricity. That is, water is a good conductor of electricity. So, to get rid of him from the electric current, we can use any wooden stick which is wet, which is not wet. Next, why do electric linemen wear rubber gloves in their hands while doing electrical works on an electrical pole? Because rubber is the good insulator. It's a non-conducting material. We know that all materials are made up of the basic building block, the atom. An atom in turn contains electrically charged particles. Many of these particles are fixed to the atoms, but in conductors, there are lots of particles that are not held to any particular atom but are free to wander around randomly in the metal. These are called free charge. Do you know about short circuit? You may have observed the spark in the electric pole located nearby your house. Do you know the cause of this electric spark? This is due to the short circuiting of electricity along its path. A short circuit is simply a low resistance connection between the two conductors supplying electric power to any circuit. Arc welding is a common example of the practical application of the heating due to short circuit. Conductors and insulators. Based on the property of conductance of electricity, substances are classified into two types, namely conductors and insulators. The electrons of different types of atoms have different degrees of freedom to move around. With some types of materials, such as metals, the outermost electrons in the atoms are loosely bound and they chaotically move in the space between the atoms of that material. Because these virtually unbound electrons are free to leave their respective atoms and float around in the space between the adjacent atoms. They are often called as free electrons. Let's imagine that we have a metal in the form of a wire. When a voltage is connected across the ends of the metal wire, the free electrons drift in one direction. So, a really good conductor is one that has lots of free charges, while those who don't have enough free charges would not be good at conducting electricity. Or we can say that they would be poor conductors of electricity. Conductors. Conductors are the material whose atoms have electrons that are loosely bound and are free to move through the material. A material that is a good conductor gives very little resistance to the flow of charge on the application of external voltage. The flow of charge is nothing but the flow of electron. This flow of charge is what constitutes an electric current. A good conductor has high electrical conductivity. So in general, more the free electrons, the better the material will conduct. See in the given picture you can see the conductors offer less resistance to electrons because the arrow mark shows the flow of electrons through the atoms. Next, insulators. Those materials which don't have enough free electrons are not good at conducting electricity, or we can say that they would be poor conductors of electricity, and they are called insulators. An insulator gives a lot of resistance to the flow of charge. During the drift of the electrons in an object, when an external voltage is applied, collisions occur between the free electrons and the atoms of the materials also affect the movement of charges. This you can understand by the given picture. These collisions means that they get scattered. It is a combination of the number of free electrons and how much they are scattered that affects how well the metal conducts electricity. The rubber eraser does not allow electric current to pass through it. So rubber is a not conductor of electricity. Rubber is an insulator. Most of the metals are good conductors of electricity, while most of the non-metals are poor conductors of electricity. Do you know the chip which are used in SIM cards, computer and ATM cards are made up of semiconductors, namely silicon and germanium. Because of their electrical conductivity lies between a conductor and an insulator. Effects of electric current. There are three main effects of electric current. They are heating effect, magnetic effect and chemical effect. First we are going to see the heating effect. When an electric current passes through a wire, the electrical energy is converted to heat. In heating appliances, the heating element is made up of material with high melting point. An example of such material is nichrome, an alloy of nickel, iron, and chromium. See, the heating element nichrome is covered with a layer of electrical insulation in the electric kettles. The heating effect of electric current has many practical applications. The electric bulb, geyser, iron box, immersible water heater are based on their effect. These appliances have heating coils of high resistance. Generation of heat due to electric current is known as the heating effect of electricity. Do you know? Wires made of copper and electrical conductor have very low resistance. Copper wires are used to carry current in households. These wires are in turn enclosed in electrical insulators or materials of high electrical resistance. These materials are usually made of flexible plastic. The factors affecting the heating effect of current are electric current, resistance, time for which current flows. See, next we are going to see the application of heating effect of electric current, the electric fuse. Electric fuse is a safety device which is used in household wiring and in many appliances. Electric fuse has a body made up of ceramic and two points for connecting the fuse wire. The fuse wire melts whenever there is an overload of the current in the wire. This breaks the circuit and helps in preventing damage to costly appliances and to the wiring. In electrical devices, a glass fuse is often used. This is a small glass tube in which lies the fuse wire. Next, we are going to see MCBs, miniature circuit breaker. MCBs have been replacing electric fuse from wiring at most of the places. The electric fuse has a big practical problem. Whenever the wire fuse, one needs to replace the wire to resume electric supply. More often than not, this proves to be a cumbersome task. Miniature circuit breaker break the circuit automatically. One just to switch it on to resume the electric supply. Many models of MCBs have built-in mechanism by which the electric supply is automatically resumed. Magnetic effect of electricity. The next effect of electric current is magnetism. In 1819, Hans Christian Ørsted discovered the electricity that has a magnetic effect. Come, let's learn the activity to know about the magnetic effect of electricity. The materials we required are the iron nail, battery and switch, then the wire. Take around 75 cm long piece of insulated flexible wire and an iron nail say about 8 to 10 cm long. Wind the wire tightly around the nail in the form of a coil. Connect the free ends of the wire to the terminals of a cell as shown in the picture. Place some pins on or near the end of the nail. Now switch on and switch off the current. What happens now? When the switch is kept on position, the pins start to cling to the end of the nail. When the electric current is switched off, the coil generally loses its magnetism. Such coils are called as electromagnets. The polarities of both ends of the coil changes according to the direction of electric current passes. Application of magnetic effect of electric current. Electromagnets. Magnetic effect of electric current has been used in making powerful electromagnets. Electromagnets are also used to remove splinters of steel or iron in hospitals dealing with eye injuries. Electromagnets are used in many appliances that we use in our day-to-day life, namely electric bell, cranes, and telephones. Let us know how the magnetic effect of electric current is applied in telephones. In telephones, a changing magnetic effect causes a thin sheet of metal, that is diaphragm, to vibrate. The diaphragm is made up of a metal that can be attracted to magnets. The diaphragm is shown in the picture. The diaphragm is attached to spring that is fixed to the earpiece. When a current flows through the wires, the soft iron bore becomes an electromagnet. The soft iron bore is also shown in the picture. The diaphragm becomes attracted to the electromagnet. As the person on the other end of the line speaks, his voice causes the current in the circuit to change. This causes the diaphragm in the earpiece to vibrate and producing sound. So we can able to hear the voice. Chemical effects of electricity. Chemical reactions happens when electricity passes through various conducting liquids. This is known as chemical effect of electricity. You will learn chemical effect of electricity in your higher classes.